everyone, welcome to today's session. My name is Zoran. I'm Senior Solution Virtualization Architect at Skyera company in San Jose. Today I will show you Skyhawk Enterprise Storage performance on vSphere VDI environment during virtual desktop provisioning, boot storm, and during standard virtual desktop user workload. First, let me provide a brief overview of Skyhawk Enterprise Storage product that we will use for today's session. Skyhawk is a mainstream enterprise solid-state storage with capacity up to 44 terabyte before compression. We can achieve up to 400,000 IOPS with integrated networking, iSCSI and NAS in one rack unit. The power consumption is only 350 watts. For more information about our products, please visit our website at www.skyera.com. Now let's take a look at environment of today's session. Today I will use one Skyhawk Enterprise Storage device for vSphere VDI deployment. We have 6 physical servers with ESXi 5.5 installed. Environment is organized in 3 vSphere clusters. Each ESXi server is connected to Skyhawk storage device using Dell Force 10 Gigi switch. Software iSCSI initiator is used for iSCSI connectivity to the storage. The task here is deploy 600 virtual desktop using VMware View Horizon and VMware View Composer for a linked clone. Storage is a heart of any virtual desktop infrastructure, and key point is latency. That will be our focus of today's session. During this task, we will take a look at Skyhawk storage performance using vCenter Operation Manager for View. We will put accent on 3 things: storage performance during provisioning task for 600 virtual desktop, storage performance during boot storm process, and storage performance during standard virtual desktop users workload. So let's start. First, let's take a look on vSphere configuration. On service cluster, we have 2 ESXi hosts: vCenter server, View Horizon connection server, and View Composer running on this host. We will use those server for VDI deployment. Here is also vCenter Operation Manager for View. We will use vCenter Operation Manager to monitor storage performance during those tasks. For virtual desktop deployment, we need to have master image with created snapshot. This image will be used by View Composer server for linked clone. I have already prepared master image for this deployment. This is one Windows 7 professional virtual machine. After virtual desktop is successful provisioned, workload will simulate standard desktop user behavior and will start automatically. For this purpose, I have set up scheduled task to automatically run different workload after provisioning is finished. Okay, let's open View Horizon Management Interface. Go to the pool setup and let's make one virtual desktop pool. That will be one automated pool, floating. We will use View Composer linked clone. I will give ID and display name for this pool, SkyHR or Human Resources. Next, desktop will be having one monitor with this resolution. I will enable HTML access to allow client to connect to the desktop using internet browser. Next, name pattern will be same as the pool name with incremental number suffix. This time on this pool we will provision 120 virtual desktop with 10 spare desktop and 2 desktop available during composer maintenance. All desktop will be up front. Next, we do not need file redirection. Next, next. Let's take parent VM, which is one prepared image, Sky Gold Image 1. Select snapshot for this gold image. Select file location. I have already prepared location for this pool. That's Sky HR. Let's select cluster. We will use cluster Skyera cluster 1. We don't have special resource pool. We'll use cluster resource pool also. And select data store. I will select 3 data store, pool 1, pool 2 and pool 3. Next. Use view storage accelerator is selected by default. I will keep them. I will keep default Active Directory location for virtual desktop, and I will use customization specification sysprep already prepared in vCenter Server for Windows Server 7 image. Alright, look overview of configuration and just click finish. To speed session time, I have already prepared 5 additional virtual desktop pool to have 600 virtual desktops. Let's take overview of provisioning process in vCenter Server. This process is a fast. For 600 virtual machine, we have spent less than 1 hour to get full provisioned virtual desktop. Let's open vCenter Operation Manager for View console to see read-write latency time during provisioning process of virtual desktops. We'll take a look at all data stores on Skyhack storage device. I call it this data store pool 1, pool 2, 3, 4 and 5. Okay, data store pool 1 has 4 milliseconds write and 2 milliseconds read latency. Data store pool 2 has 4 milliseconds write and 2 milliseconds read latency also. Data store pool 3 has 6 milliseconds write and 4 milliseconds read latency. Data store 4 has 2 milliseconds write and 2 milliseconds read latency. That is wonderful result because virtual desktop provisioning required a lot of storage resources. If we open Skyhawk management interface, we will see storage utilization during the provisioning process. These dynamic diagrams show us throughput and latency for all LANs in real time. After the provisioning process has almost been completed, let's open View Horizon Management Interface again. In this time, we have 528 virtual desktop full provisioned, connected, and this desktop running standard workload to simulate standard virtual desktop users. Time is for Bootstorm. To simulate Bootstorm, I will select all running virtual desktop and reboot all of them in same time. This step will generate more workload than classic Bootstorm, but that is a good way to simulate this workload process and take the performance results. Okay, restart. Let's go back to vSphere client to see this process. This process is very fast and all virtual desktop will be rebooted in a short time. Take a look at the performance during the Bootstorm workload. In vCenter Operation Manager console, I will show you latency performance for some of the data store. Data store pool 1 has 6 millisecond write and 4 millisecond read latency. Data store pool 3 has 9 millisecond write and 10 millisecond read latency. And data store pool 4 has 7 millisecond write and 9 millisecond read latency. Bigger read latency than write latency in this moment is caused by bigger read request during reboot process. Reason: most I/O request is a read request. After bootstorm process is finished and all virtual desktop is up again, let's open Skyhawk graphic user interface. This graphic diagram shows us peak time when boot process happened. You can see after short time boot storm process is finished and virtual desktop continue with normal workload process. Open vSphere client again. Now we have 625 virtual desktop which are powered on, connected and running workload. Let's open one of them. Each virtual desktop running same workload, simulating standard user behavior. Some of these tasks are streaming video, running Microsoft Office application like Outlook, PowerPoint, Word, Excel, make calculation, browsing web contexts, and many other. Let's see latency performance during virtual desktop standard workload. You have to see data store pool number 5, pool 5. On this data store we have 131 virtual desktop running. On event and workload graphic you can see the peak time when actually bootstorm happened. Each virtual desktop running workload index 3D or more. Take a look about latency on this data store. Read latency is 0.87 milliseconds and write latency is about 2 milliseconds. We don't want to show you only performance numbers on paper. This video shows you real performance number in our lab environment, very similar to production environment. Skyhawk Enterprise Storage is able absolutely address all your requirements for virtual desktop infrastructure deployment. We are able to support more than 4,000 virtual desktop in one rack unit. That's all for today. In next session I will show you similar VDI environment but using Microsoft Hyper-V virtual platform. Don't forget to visit us on address www.skyera.com for more information about our products. Thanks for watching.